Hey, you have reached Saturday Science Chats. We have a great show today. You don't want to miss this. Yes, indeed. Yes, indeed. You have reached Saturday Science Chats, sponsored by the John Chappell Natural Philosophy Society and Dissident Science. And of course, today it's a real special day. I told you this year we're going to be honoring a lot of the great scientists of our generation. And today we are honoring Glenn Borchardt, Dr. Glenn Borchardt, with a lifetime achievement, well overdue. My goodness, I don't know why we haven't done this before. For infinity, 10 assumptions, and other things, of course, in my opinion, he has written himself into history, whether he likes it or not. So we will be talking about him. Of course, we will be doing more Lifetime Achievement Awards this year. We've already presented one to Nick Percival, also the Glenn Borchardt. I think that's one of the things we can do. We've been around almost 30 years, and this is something we can do since mainstream science is way behind and have not caught up to what we in the critical thinking world thinks are the really great works and the great people in our circle, that this is a responsibility that we have to recognize these people in their lifetime for their amazing work. So expect more achievement awards this year. And our chats format, of course, is every other Saturday we are going to be doing general topics with myself and Dissident Science. Dissident Science is my YouTube channel. I want to thank all my subscribers. I'm coming up to 5,000 subscribers. I do promise you guys, I've been so busy with my work. I actually have a real job and home life that I've just been inundated. So I have not been able to do some things on my YouTube channel specifically. But for these sessions, we're putting together the CNPS and the Dissident Science YouTube channel. I want to thank all the subscribers. And of course, we're looking forward to other presentations on the every other Saturday from the CNPS and more in-depth topics. They're hosted by Ian Coyne. Ian Coyne is a really great mind, big thinker, critical thinker we have, who hosts us this channel usually every other Saturday. It's not perfect, our system, but they have really great topics. So if you're really into much more, in-depth, you can see some of him's things being discussed. A lot more nerdy, more scientific. So it really gives everybody on all sides a chance to really enjoy the real critical thinking, where our thought process is free. We can think what we want. We can learn what we want. Nothing is written in stone. And this organization, of course, does support that kind of thinking. So you don't want to miss that. Really, I think they got topics lined up already into March. Well, March is right around the corner, but you don't want to miss that. And of course, like I said, we'll be here mostly every other Saturday, talking about the general topics, a discussion like the Lifetime Achievement Awards. Of course, we do have our websites, naturalphilosophy.org, which is our community. So if you want to go in there and talk about ideas outside the mainstream, again, we are a scientific organization. We don't throw, some people think it's just like you throw away, oh, you guys don't follow scientific method. Actually, we're going to learn today, we follow the scientific method much more than mainstream, and that's why we're so critical of it, because they don't. A lot of people in physics, 99.9% of the physicists don't agree with theoretical physics. A lot of them, well, a majority of them don't. So this is where you can get together with other like-minded people and discuss topics that are near and dear to your heart, from everything the Big Bang, particle physics, consciousness, specific models, new models of the universe, Big Bang, relativity, and et cetera, et cetera. We also have an online magazine, which is a really good website. It's beyondmainstream.org. So if you're kind of new to this and you're not into the nerdy part of it and the nitty gritty, you don't know what Michelson and Morley experiment is, then you can check that website out, beyondmainstream.org, and it will kind of ease you in, and you can click on things like, what do you mean mainstream science has got problems? Well, boy, does it have problems. A lot of people know it. It's just that we are out there really trying to solve the problems. In my opinion, the critical thinkers, these groups, including Dr. Glenn Borchardt, were way ahead. In fact, it's our contention, like people like Dr. Glenn Borchardt will be a part of the regular mainstream science someday. We also have a Wiktionary of over 10,000 pages, wiki.naturalphilosophy.org. And you can become a member. You can become a member and a supporter of our group by going to naturalphilosophy.org and sign up for a membership. We have as little as $35 a year, or you can do it monthly, like $5 a year. And we have people who are much more generous, $25 a month. All of those things are very important because we, in fact, live on our donations, and we have almost $3,000 just in all the things that you see, the websites, our server where the websites reside, our naturalphilosophy.org, the software we use just for memberships. That's, believe it or not, membership software that you collect memberships costs money. It's just the way it is today. So it would be greatly appreciated, your support of critical thinkers outside the mainstream. So your support is I thank you for it, and is welcome. And of course, like I said, we do have our monthly and annual memberships. You can make donations, and you can go to membership.philosophy.org and then, of course, come in and help us out. But today we are going to be presenting our Lifetime Achievement Award to Dr. Glenn Borchardt. And we're going to talk about, I'm going to give you a little introduction to Glenn here, but he is certainly, in my opinion, a scientist that has written himself into scientific history. And we're really honored to have him here today. I've known him for many years. He's been a great influence on many of us. Absolutely. I can tell you that my dad and I's work doesn't even exist with what he has established in the scientific world. He's just a great, great mind. So past recipients, of course, there's some pretty big names up here. Of course, if you're not in the critical thinking kind of quote-unquote dissonant world, you may not know this. Halton Arp is very famous. In fact, we did present him quite a number of years back. He's been gone for a while, but he was really very ill, and I had suggested to the NPS at that time that we present a Lifetime Achievement Award to him because he has done such great work. And of course, he was ousted by the mainstream for daring to show concrete evidence that the Big Bang had big problems. And so I remember, in fact, we had a video, and I don't think we have it anymore, but I remember seeing the video. He was quite frail at the time, but I think Dr. Peter Marquardt, who I'm trying to get also, he is one of the people I'd like to honor as well with this award, but he and some other people got together and presented this to Halton Arp in Europe at the time. So it definitely is some people are people that are pretty big in this community. We had Ron Hatch, of course, who recently passed away. He was an expert, to say the least. He was a worldwide expert in GPS, and one of the few people that stand up and says, GPS does not support relativity. In fact, it shows the flaws in relativity. Dr. Bill Lucas, also a really brilliant mind. His universal force equations, if you haven't read his work, pretty intense, but a really brilliant mind. Dr. Ebley Spencer got her PhD in mathematics from MIT and was a big proponent of criticizing relativity, the Big Bang, all of those things. Actually, not an etherist, kind of like myself. My father was one of the few people. She would always argue about, every time anybody would get up and talk about ether, she would get up there and argue. But again, just a brilliant mind. Dr. James Maxlow, really great guy, works on expansion tectonics. Walt Thornhill, electric universe, of course, who just recently passed, just this month, actually. Sorry to hear that. Really great mind. I admire the electric universe people. I don't agree with everything, but that doesn't matter. What it matters is they are out there now criticizing relativity because 15 years ago, they kind of looked at us and said, look at those guys, they're anti-relativity. Next thing you know, go on the YouTube, search Walt Thornhill and relativity, you'll find out they kind of got on the boat there. And of course, our own Nick Percival, who very recently, who was given the award. Oh, also, gosh darn it, I'll have to put him on there. The guy with the fourth phase of water. Water has actually a fourth phase, which is interesting. We think of the three, gas, ice, water, but there's actually a fourth. Very amazing guy too. He received this award very recently. So let's talk a look about Glenn. He got his Bachelor of Science in Soil Science from the University of Wisconsin, Madison, and also claimed a neurology master's, and his PhD in soil mineralogy from Oregon State. He is now on the West Coast, has been there for a while, and made quite a good living in geology, looking at faults and those kinds of things in California. So I think he had plenty of work to do. He's now retired and living in a snowy area. But Glenn has over 50 years of practical and theoretical experience in earth science. He has produced over 400 scientific reports, including consulting reports, journal articles, book chapters, books, and computer programs. Borchardt is also the director of the Progressive Science Institute in Berkeley, California. We'll talk a little bit more about that. I subscribe to his blog. You should. He puts them out every couple of weeks. Really kind of short things, but very, very thoughtful and answer questions. So you should absolutely. We'll talk about that. Now, this is in his own words. I think it would be nice. I do have his biography, but he says, this is from Amazon. He says, I have over 60 years in theoretical and experimental observational experience, interested in scientific philosophy. Although I have produced over 500 scientific reports, including journals, articles, chapters, books, computer programs, we read that. The best by far is my book, The Scientific Worldview, Beyond Newton and Einstein, Understanding the Universal Mechanism of Evolution. That was published in 2007. If you want to buy any of his books, well, that's one of them. That's his early book, but that to me is a seminal work. It has the 10 assumptions of science. It poses the ultimate challenge to the current wildly popular, though absurd claim the universe is finite and it exploded out of nothing. I mean, now I've known Glenn for many years. It almost hurts me to even read the universe is finite, explode out of nothing. It's so. I mean, it really sounds like voodoo. It sounds like magic. It doesn't sound like anything like science. But the book is completely logical from the beginning to the end in support of an infinite universe and the scientific philosophical approach that will replace the Big Bang Theory and the systems philosophy supporting it. The challenge for me is to get readers intelligent enough and educated enough to handle these ideas presented and to understand the book's great significance. It truly is. The paradigm that I propose is antithetical to conventional physics and astronomy and cannot be taken seriously by those who hold the idealism of mathematics to be the true test of reality. A detailed technical review of infinite universe theory was published by Steve Putz, and as Universal Cycle Theory, and a follow-up book written by for layman, released in 2017, The Infinite Universe Theory. Very good book. There's another one you should read. All of these books are great. And the latest, The Religious Roots of Relativity, which introduced the 10 assumptions of religion as the indeterministic opposites of the 10 assumptions of science to explain the popular and tenacity of relativity and cosmology prognosy. So yes, he has actually brand new book. I haven't really talked to him about that, and we'll talk to him, I'm sure. I'm going to read some of the his biography from our wiki. So let's see where we can go. The opposing assumptions, he says, okay, I'll read this whole thing. As a director of the Progressive Science Institute, Borchardt published the 10 Assumptions of Science toward a new scientific worldview in which he outlined 10 fundamental non-provable beliefs that served as a foundation of all science investigations. The opposing assumptions, just as non-provable, were considered the foundation for the belief in the supernatural. His assumption of microcosm and macrocosm infinity is a thread running through each of the assumptions. Their suitability was shown by their consubstantiality. Oh, that's my favorite work. My favorite word comes from him. Consubstantiality. I don't think I'm pretty sure he didn't come up with it, but I love it. It means self-consistent. So consubstantial are your theories and ideas self-consistent. That is, if one can assume one of them, one can assume all the others without contradiction. The work was published with conventional scientific theory admitted to few assumptions, though the belief in infinity, and not, oh wow, that is funny. It's a linguistic, whoa, look at that linguistic funness there. Me being a linguist, look at it. Through the belief in infinity. That is pretty funny. And matterless motion, yeah, that's another one. Matterless motion clearly was manifest in the popularity of the Big Bang. Borchardt's assumption implied the universe had no origin. And if you don't know about his works, you can go to Amazon, and here are all his books. You have The Infinite Universe Theory and Religious Roots, RRR, that's why, Religious Roots of Relativity. Here's the Infinity Theory in French, all those French Canadians, and then the 10 Assumptions of Science, the Universal Cycle Theory, and the Scientific Worldview. You can buy this Scientific Worldview, and I think it includes the 10 Assumptions of Science. Let's look. You can look a little bit closer here. 10 Assumptions of Science, I think, was his first book. Second book was Scientific Worldview, Beyond Newton and Einstein. You can see already the director of the Progressive Science Institute. I guess I am part of that because my father and I are part of it because we are disciples of this man's work. And then he came out with a book that I myself, when I read, and I read Neomechanics and the infinity all the way up and infinity all the way down, which I kind of took one of the famous sayings is turtles all the way down. You know, where if the universe is standing on the back of a turtle, what's it standing on? It stands on another turtle. It's turtles all the way down, kind of. But I said in his the Neomechanics and infinity, infinite universe theory, it's turtles all the way up and turtles all the way down. I remember when I read the infinite levels up and down, I was so blown away by it. I've been blown, my mind's been blown a couple of times, and this was one of them. And I remember calling Glenn Borchardt up and just chewing his ear off. He probably just thought I was nuts, but I mean, I got it, and it, never stuck with me ever since. Of course, these are his newer books, more for the layman. Glenn is a true scientific philosopher. I think he's way bigger than Coyne. We always think of, paradigm shift and all that stuff. Coyne was kind of, talking about a kind of just one part of it. This is true scientific philosophy, and that's why I think he's written himself into history. And check out his new book. I have not checked it out. I've been just too busy, but I'm looking forward to reading that. And of course, his Scientific Worldview you can get to by going to sciencephilosophy.com. I'll put that down here so you can see that at the bottom of the screen there. So you can go to scientificphilosophy.com, and there you can subscribe to his blog. He's got just tons of articles. They're pretty short, so you don't have, in our days where we're very busy, it's really great. So you can go ahead and subscribe, and you'll get these things in the mail, and you can click on them. He puts them together. He's got to have hundreds of blog articles. Always really great. He always answers a lot of questions from people about his work, so you do want to check that out. Also, his Neomechanical kind of world, infinite world, I should put infinity up there too, has been very much embraced by numbers of us. The four people up there are complete, I guess, disciples of his work. Stephen Bryant, we'll talk a little bit about each of these a little bit. George Coyne, who's here today, because he is... he, like myself, are extremely indebted and admire the scientific work of Dr. Borchardt. Myself, and of course my dad, which is a pretty interesting story, and other people who are in the Neomechanical world, whether they want to know it or not, are Jeff Yee, who's got a completely Newtonian version of the universe. You can check out his energy wave theory. Incredible work, really. And Laurie Gardee, who also has been working on various things. We met in Vancouver, and when we were still doing our in-person conferences, and she also is a person that lives in the Neomechanical World, and I'm sure admires Glenn's work. And here's Stephen Bryant. If you haven't checked him out, is Modern Mechanics: An Alternative to Relativity. Of course, one of the main themes with Glenn's work, his 10 assumptions of science, really kind of obliterate things like the Big Bang and relativity. So it's not surprising to get really brilliant minds like Stephen Bryant, who has a book out called Disruptive: Rewriting the Rules of Physics, and talks about modern mechanics and alternative to relativity. If you read his book, really great book. You do want to check that out. George Coyne, who is here today, not affinity process, matter and emotion. Yeah, matter and motion. I've kind of heard that from somewhere. Oh yeah, Glenn Borchardt. That's one of the things he talks about, or motion. It's you can't have matter without motion, and motion without matter. But I love the way Glenn talks about things. He talks them very, very scientific and philosophical, but when he says them, even though he doesn't inflect them like an actor, it is, when he talks about mainstream stuff, he talks about it in kind of a, it's hard to believe they do these things or say these things. You can also see in this book, talks a lot about the Big Bang. I don't know, 60 some, almost 70 reasons why the Big Bang is wrong. Also talks about consciousness. If you're into that, this is a good book. I've heard people talk about consciousness, and it's no offense, it's been really bad. It's kind of like New Age mumbo jumbo, where they talk about things like, things, and they make this system, this arbitrary system, and they start talking and they label everything. It's kind of like Dr. Alexander Unsker, who says particle physics is a bunch of people who put together arbitrary packages with arbitrary attributes. I've seen that's done in the consciousness, but this is not that. I'm a computer scientist. I think one of the reasons I really enjoyed this book by George was because as a computer programmer, if you had that kind of logical brain, it is just really well. I really recommend it. But here's a little quote from actually Amazon, where he says, Glenn Borchardt's Infinite Universe Theory, Universal Cycle Theory, and Neomechanical Gravitation, co-written with Steve Putz, are described. So obviously, and then myself and my dad and I are doing a new book. I think it's kind of like Glenn. We didn't really realize what we had. Our first book was Principia Mathematica, 2, but then we did, literally this last year, after it's been published for a few years, I was sitting in the car with my dad. I said, we got to step back and look at what we really have. And we came up with what what we call now the four universal motions in physics, gravitic, magnetic, luminic, and electric. And we did. I invented a new word. I feel like, I'm following my mentor or my guru's footsteps, Dr. Glenn Borchardt. And it's really interesting, too, that even though our model's different, it's not an etheric model, it still follows all the principles under Dr. Glenn Borchardt's Infinite Universe Theory, Neomechanics. And it's interesting because I knew and was already a disciple, more or less. Can I say that, Glenn? I mean, you just wrote a book about religion, and I'm sure he's like cringing that we call it so. Well, follower or a student, I think is best. Yeah, I'm a student of his work. And I already knew about the infinite levels of the universe. I was totally convinced it has to be that way. And my dad is never. My dad is a skeptic to the end. I spent 8 years making the documentary Einstein Wrong. I'll go to EinsteinWrong.com. You can see that. But anyways, he when we had the premiere, I think it was in 2017, the premiere in the theater there, and afterwards you have that panel and stuff. Ron Hatch was there. My dad was there. I turned to the audience, really loved the film. And then afterwards, the question and answer, I said, Dad, okay, we've been doing this 8 years. The name of this film is Einstein Wrong. So do you believe Einstein wrong? He goes, I don't know. I don't know myself. I haven't investigated. 2 years later, he shows up at the CMPS giving a paper on how special relativity can't be. And he came up with his own, it doesn't take much long. If you actually have logical brains, you'll find out it doesn't take much to actually disprove it. But so my dad, I told him about all these infinite levels and that's the way the universe works. And then, He's an electrical engineer. We started applying the what we call the four universal motions to everything from magnetism to finally electronic components, which really has revealed new things that we've discovered that made predictions we couldn't see, and actually describes a much more sane world of electronic components. By the way, the electricity part of it, Glenn, came from your idea that electricity was really ether captured in wires. Ours, again, is a different model, but it was inspired by that. But I remember one day he came to me, and we have Coulomb's law and gravitational equations that look the same. And my dad turns to me and goes, we know, of course, Coulomb's law and the gravitational law, the reason the functions that describe, Coulomb's law and Newton's gravitational law are r squared, and they look identical, is because they are both gravitic fields. They're just with different bodies. We call them bodies now instead of particles. So you have the gravity bodies, what we call G1s, that keep what we see as gravity. And then there's a gravity down one level with particle bodies that are faster, smaller. And that's going to be in our new book. And I just now he gets it. And that at that point, he became a disciple of Glenn Borchardt, but he had to check it out, Glenn. He didn't believe it. So anyways, that's our story about it. Without him, he's in the book. He's listed as, without him, this book and our work wouldn't exist. So, again, thank you. Why I'm such a big fan. And he has his 10 assumptions of science here that we're going to talk about, and we're going to present him with the award. But right now, I want to just take this down and bring him up here and talk with him. Again, you can go to Scientific Worldview, and we'll just start talking with him about things. And I've got some questions for him, and then we'll present him, of course, with his Lifetime Achievement Award. But let me bring up the recipient today of our CNPS Lifetime Achievement Award, Glenn Borchardt. Glenn.
Oh, thanks.
How are you?
Yeah, I'm fine, and hope you're okay. And I'm sorry to hear about Wall passing. I realized that. And he was one of the big guys that questioned the modern physics, as they call it. And so anyway, thank you so much for the award. I really appreciate that. You have a really remarkable list of previous winners. Like Halton. I had heard him speak a long time ago in San Francisco, and he was one of the inspirations for a lot of my work. So, it's really great. And so anyway, you must have some questions for me.
Oh, yeah, absolutely. I mean, first of all, I do want to congratulate you. I met you in the CMPS and was listening to you, and it took a few years for the things to sink in. But once I kind of got it, I really understood. And I knew that this was going to happen someday. I didn't know I would be honored enough to be a person to present you with the award. But I think that the one of the things that I noticed since I've known you, you were just talking with words and about people that was completely out of my realm, which is philosophy. I love philosophy. I've worked with philosophy only in a more limited way with linguistics, because we have linguistic philosophers for language. And, for instance, you can say I am seeking a unicorn, and there are people who look at the logic of that and say, well, there are no unicorns, but you can be in the relationship of seeking to something that doesn't exist. But that was my only kind of venue into philosophy, because really I look at you as a scientific philosopher, really, for and foremost, and I think that's what you're going to be looked at, even though all the things you came up with. How did you get it? I mean, you would solipsism, or you would say these words and you would talk about philosophy, so I could see that you had read an incredible amount of philosophy before you came up with your work. So you didn't just you weren't like, who cares about philosophy, sit around. You seem to be rooted. How does a geologist go from geology to reading almost, I mean, a lot? I'm sure you read a lot about philosophy. How did you get from geology to philosophy?
Well, it happened actually. You asked me this question before. When did I end up being opposed to the Big Bang? And what happened is that in early '78, I was a Big Banger, like everybody else. And then I got to thinking more about it. I said, "No, this is nuts. The whole universe is exploding out of nothing. What's the deal here?" And by the end of '78, I had made big switches. So then I started to work on the scientific worldview. It took me about 7 years to finish that. And that was really because I did read about a lot of this stuff. I think a lot of it, I used to spend my lunchtime and so on reading about New Scientist, for example, some magazine, Scientific American and Science Magazine, these things and they would talk about the Big Bang and stuff, and I would just shake my head and say, "Oh my!" So and I would do that, and then I think the most important philosophical thing was Collingwood, and remember you mentioned him, and he in 1940 he wrote this book, an essay in metaphysics, and in science generally we think of metaphysics is worthless because we just do science. We just do experiments and observations, and and philosophy is generally denigrated among scientists, and you'll hear that like Neil deGrasse Tyson. He was saying, "Oh, philosophy's harmful. It's not even useful for us at all." And partly that's because philosophy has been tied with religion a lot. And of course, we're not doing religion, we're doing science. And so that was the thing. But the thing about Collingwood was interesting. I went to the Berkeley Library and I saw this book called An Essay on Metaphysics. And yeah, I thought, well, that was in the section where I was considering, studying this stuff a little bit. And well, I passed it up about 3 different occasions, but finally I said, well, I guess I'll have to look at this. And it's true, about half the book is nonsense, but the important part was the scientific part, and where he simply said, look, there are fundamental assumptions, and they always have opposites, and they can never be proven. Infinity, for example, infinity, these are examples of that, and you have to choose which one you want. And of course, the current guys in astronomy and cosmology have chosen infinity, and they don't realize it. That's why Collingwood had said, look these are presuppositions. These are things that people hold, but they don't recognize them. And he says, when you bring them out in the light of day, you write them down, then they become assumptions. You can study them and see which ones might be consupponable, like you were saying. And consupponable was used first by Collingwood in 1940, and W.H. Alden was the other guy, and then myself, and I found it very useful. And con means with supposition. So if you pull, as long as they don't contradict, and that's really good. I got another word for you. It's called parologist. What's a parologist?
Well, it sounds like something in medical field.
I know you're really into logic. Okay, well, paralogic,
yes, absolutely,
side of logic. In other words, a paralogist is a person who uses incorrect assumptions. The logic,
wow, I've never heard that.
Correct. Okay. They also, you could make a mistake having an assumption and then not getting the right deduction, but that's the key to parology. And I think that's a great word, because I wanted to have some idea. Well, somebody who's not thinking right, they're a parologist. And para is outside, like paramilitary and so on. I thought it was really a good word. So
anyway. It kind of describes everybody who kind of comes up with a bunch of. I think what happens with those kinds of people, parologists, right? They basically come up with these assumptions that already are not consupponable. There's all kinds of problems, and then they spend all their time up here building on these assumptions, and no one, you try to go back to those and they don't seem to care. In fact, I think a lot of modern physics is that way, right? They're based on all these assumptions, and now they're just spending decades and millions of people and PhDs writing about this stuff, and it's in a house of cards.
Yeah, it's like having big debates over how many angels on the head of a pin.
Right.
You can argue about that all you want, but see, the assumption base is like, number one, that you have angels and that they're small, number two. And so now you can argue about what the size might be and so on. But you're using the wrong initial assumptions. See, that's the problem with.
Right.
Okay, so with the that's why I call the folks. I don't call them Big Bangers anymore. I call them cosmogonists, and the only time you see cosmogony, that's the assumption that the universe had a beginning. The only time that it has been used in publication is when Lemaitre actually had this in his 1931 initial thing about he's the father of the Big Bang, and he had actually mentioned this was a cosmogony, and I'm using it more and more now because it is of a cosmogonist is one who assumes the universe had a beginning. Then okay, that's fine, you can have that. But the big question is, well, okay, if you've got that, what are the results? What do you get? And so the things have gotten so absurd now with whole universe exploding out of nothing. Or sometimes to get off the hook, they'll say it was a singularity, or it was produced by dark energy or some other silly stuff. And so that's where we're at right now. And so as a earth scientist, I had a minor in geology. I really wasn't a geologist, and I had a minor in chemistry, and those are pretty broad fields, and especially soils, because the whole planet's covered with this stuff on the surface that without it, we would not be actually living here, because you got to have soil to grow the plants that we eat and so on. And that's why soil for me was fascinating. I really started out in wildlife management because I'm a big hunter and trapper when I grew up on the dairy farm in Wisconsin, and nothing else to do except that, and doing some other things we had to do. And so that is really was really amazing to me, because when I first took that wildlife management, they didn't have a degree in undergraduate, so they put me into soil conservation. All right, so I took a beginning soils course, and it was amazing because not only did it have chemistry, it had physics, had anthropology, archaeology, and it just went on and on. And so that's how I got into that. And then, of course, when I worked at Oregon State University, I did neutron activation analysis. A little complicated, but what we did is we bombarded samples with neutrons, and we made these samples radioactive, and we could get like 25 different elements, and we could then compare one sample of volcanic ash with another. And we worked on Mount Mazama, Crater Lake, and on the soils. We took soils up towards the northeast, and then we ran into another ash. It turns out it came from Mount St. Helens. And, this work is done in the late 60s, and we actually put borings into peat bogs to figure out where these samples of ash came from, because this was lying on top of messing up our ash from Crater Lake. And anyway, we kind of predicted that Mount St. Helens would erupt, and of course it did in 1980.
Right.
It was kind of a neat thing. So whenever you have a prediction that actually works, it's kind of neat. And so then I got, of course, more involved. I spent 40 years studying this scientific philosophy. Now, let me explain a little bit about philosophy of science and scientific philosophy. First of all, the philosophy of science is dominant. And mostly what it is the history of what scientists thought in the past. Now, what I call scientific philosophy is the correct philosophy of science. And now, one of the reasons philosophy is denigrated by people like Tyson is that it opposes the scientific philosophy is the opposite of what what they should be doing. So that's the whole thing about philosophy, is that, and philosophy is this theory. So if you're a theoretical physicist, the first thing you have to do is you have to be a philosopher, and you have to set up your assumptions. Now, I understood that if you're going to take down a paradigm as powerful as the Big Bang Theory, it's been around since 31, and actually 1929. And relativity is the foundation of it. And all that, you have to have, first of all, your underlying fundamental assumptions. Remember, they can't be proven. You just assume them. You can't prove finity or infinity. You just can't do it. So, but you can assume it, and when you do that, you get different results. And I've really enjoyed doing that, because with infinity, remember neomechanics, all that is classical mechanics with infinity applied. Once you do that,
Right.
you get the results that we got with neomechanics. And so, and you can explain E equals MC squared and all kinds of stuff with it. And so I'm really proud of that. I'm really glad that you guys are getting to use that as well. And also the assumptions. It's really great. And so that's kind of where we're at right now. I would like to, we do a lot of complaining about the Big Bang and stuff, and I still do. I've got really about 700 followers on medium.com. And
okay.
I really love that because, first of all, it's not censored, so you don't have the usual toss it in the circular file thing. And I really have a lot of people asking questions about the various things and so on, and I answer them. You also get, as you get a lot of complaints about anything you might say against Big Bang or Einstein, and so that's but it's been very good, and I recommend it because it's got I think Medium must have about 100 million views or
I'm not
something.
even, I'm so stupid. I don't even know Medium. Is that medium.com? What is it?
Medium, yeah, medium.com. And you can get 3 essays a month without paying anything. 3 essays, and then you can pay $50 a year and sign up under my name, and the Progressive Science Institute Foundation gets half of whatever you put in. And I recommend people do that because you can get all kinds of essays. You put in a word, and say you want to learn about Ukraine. You just put that word in, and all these essays come out. You pick them up. So it's a really good news source. It's written by individuals, so it's not corporate stuff or anything. And it's kind of like what I do, and it's really good.
So this is it. Stay curious.
Yeah, there it
Medium.
is. Yeah,
Yeah.
right. So
Okay.
you
I'll have to
do.
check it out.
Yeah, you can then search on my name, and it'll pop. Just try that once.
Where's the search?
Yeah, let's see what happens. I don't know what.
Or
Yeah.
search right. I think you have to sign in. Maybe I don't know. Start reading. Okay, let's see what that says. Oh, you got to sign in and stuff. I have to do that first.
I don't know,
I'll
you should
sign in.
find a search somewhere.
Yeah, I'm trying to do that, but I think what happens is they're
Yeah.
they're very adamant about you joining, right? So you can't even search on it. But I'll go ahead and try to join while
Yeah. So
while other
you
people are be
can do
talking
that.
here. Yeah.
And the link is also on our scientificphilosophy.org site. So you can.
Yeah. Right. Right. Okay. I gotcha.
Yeah. So you can look at that too. So.
Okay. I'll get that up and when we a little later on. So I guess one of the major things is how your 10 assumptions of science was it the other question I have a bunch of them, but one of them is the 10 assumptions of science. Let me just go ahead and I'll put those up here in a minute, but were those written with alongside your problems with things like the Big Bang, or did you come up with the 10 assumptions of science, then kind of start applying them, and of course relativity and the Big Bang kind of just blew apart? I mean, what was the kind of sequence that you had there? Did you come up with the
Yeah.
10 assumptions?
Right. It's a good question because I I was wondering why people so brilliant would, like Hawking and so on, and Einstein, how they would come up with such silly things. And these are assumptions that there. Okay, first of all, let's go this way. I didn't know what the assumptions were, right? So I was reading all this stuff. I was trying to figure out, well, okay, now what are these fundamental assumptions? That was the key from Collingwood. And so then, like materialism, causality, and so on. What kind of interpretation of these assumptions fit infinity, number 8 at the bottom? Now, this is a sequence in which I discovered them. You know,
Oh,
yeah, they're just essentially that. Now, I remember when I was in a dorm, early as a freshman in college, we had two groups of people, liberal arts students and scientists. Now, the scientists said, okay, there are causes for all effects, including, there's no free will and so on. And then the free will guys were the liberal arts guys. I said, well, and we never came to any conclusion. That was just the way it was. And why don't we come to it? Well, because we have different beginning assumptions. And like number 1, materialism. The universe is made out of matter. Matter is defined as XYZ portion of the universe, according to me. Okay. It's different from mass. Mass is a measurement of the resistance to accelerations. All that is. That's what mass is. So mass and matters, and it's infinitely subdividable, like I was talking about. And then I go through all these other. So these are kind of in the order of when I thought of them and when I considered their importance. Remember, infinity is down a little bit. It has now become really important, but you could do with the first 7, and you'd be doing pretty good. You wouldn't necessarily, but if you're going to do the 7, as I like in irreversibility, look at this. I agree with Einstein on one thing, that everything in the universe is in motion. Okay, mm-hmm. So it's all these motions are irreversible. If inside doesn't change, the outside certainly changes. So you got this interaction. And remember, what my basic theory is in the scientific worldview is called univironmental determinism.
Right.
What does that mean? Well, I was sitting around a table with my friend Elizabeth Batelke, and we were saying, well, I got to have some way of describing this interaction. What do you think we should come up with? And so we came up with the word complete, everything. So the idea is that what happens to a portion of the universe is determined by what's inside of it, the matter and motion inside of it, and matter and motion outside of it. And that's why I use the words microcosm for things, because when you use an object and so on, a lot of times you think of it as not being connected to the rest of the universe. So this is another reason this univironmental thing fit with the infinite universe theory, you see, because you always had an outside. So if you had a finite universe, there'd always have to be something outside of it, of course. And finite universe is what I call a systems theory. In systems philosophy, people overemphasize the system. And we typically do that, like when you have your computer system, you're not worried about what the weather is or anything unless the power goes out, right? But mostly you're considering only one thing. That works fine many times. But if you're going to do, this is the beyond part, essentially. Remember, beyond Newton in the scientific worldview talks about infinity, because you take classical mechanics, which Newton came up with. He's the greatest scientist that ever was and will be. And he essentially set up these 3 laws of motion. An object continues in motion. He would say, unless it hits something or gets hit by something. And what I did is with infinity, I said, until. That's a big difference. When he said unless, that means he was into finity. And Newton was interesting in that he thought, well, the universe has to be infinite, because if everything's attracted, it'd all come into one big lump eventually. And he said, well, that's not the way it is. So the universe is macrocosmically infinite. He thought the universe, the individual things were finite. And that's one of the deficiencies of his theory. And I just explain that a lot in Scientific Worldview. And I use the word microcosm instead of object, like he did, and instead of what other people do is call a system, because it's not a system. It's this interaction between the things. And remember, you go back to Darwin and his 59 Origin of Species. And everybody since he was just talking about natural selection. Remember the outside. And so what he failed to know about was genetics, because he couldn't know that at that point. Mendel eventually had that. So then the biologists come out with this, what they call neo-Darwinism, which only applies to biology. And B&I was working in soils and rocks and so on. I knew, and these were all evolving, because one of the things I do was to get the age of soils. So they're interacting with their environment, how much rain falls and so on. And I was doing that. And so I knew that really we've got to have a general, universal mechanism of evolution. And that's what I call unienvironmental determinism, that what happens to a thing is determined by what's inside of it and what's outside of it. And that applies to everything. That includes you. What's going to happen to you? Well, if you're driving down the road, you might think you can control what happens to you, but not always. Somebody wants a suicide on your bumper. That's in other words, it's an interaction. You can control a lot of things, but you can't control everything. And so that was really important, I think, in the Scientific Worldview. When you read that, you'll see that.
I remember your diagrams, because they were kind of weird looking. They were weird looking because because it was really totally conceptual. And of course, I'm an artist as well. I draw and stuff, and we're looking at that. That is so bizarre. But it really. I think one of the things that has been interesting since you've put that out into the world is that I've heard other people. Nick Percival was talking about time and things, and how it's kind of more local. And if you look at what we are, we kind of have a perception of this far up and this far down. Maybe with time we get to see more levels and think about more what's going on. And it got me to Laurie Gardee, which talked about fractals, because it's the old thing. If you look at the border, how long is the border of the United States? Well, if you go by foot increments, it's that long. But if you get it smaller, it gets bigger. It gets bigger. It gets bigger. What I thought, one of the things that your what do you call it? Unenvironments, is that in our perception, at least, of things, we seem to kind of live in a local area. We try to get a hold of, and even like with mathematics, of what we can kind of see, even though we know everything below it and everything above it is affecting it. Have you ever thought about that? Like kind of the limitations of the practicality, almost like a fractal, right? If you look at a fractal, we kind of live at the point where we can see this far down and this far up. Have you ever thought about like the locality of these things? I know you say above and below, microcosm and macrocosm and unicosm. But have you ever thought about kind of the perception of how much we can really see and control ourselves?
Yeah, right. You're exactly right. So remember, I like to talk about when a baby is born and about the age of maybe around not even 1, they put a blanket over their head and the whole world goes away.
Right.
And we were kind of like that. We like to say, okay, here we are, and here we have our house and meals and all that kind of stuff. We don't give anything about the infinite universe. Why would that affect me at all? All I want is to get lunch and so on. So that's where we were in the past. Remember, used to be that the center of the whole universe was the Earth, and we're always like that. We're myopic about that. And so what we have been doing, and humanity has been doing for the last couple centuries, is to get out of that. Ever since Copernicus said, maybe the Earth is going around the sun, and the sun is the center of the universe. And then the Milky Way shows up, and you take one step out, And then we find Andromeda. Oh, that's an island universe, they called it. And so we wake up and we see more and more stuff. And then in the other direction, microcosmically, we find all these bacteria and viruses. Now we're doing CRISPR and all kinds of amazing things to cure or stop some of the virus attacks and so on. And so it's just amazing that now, remember, Milky Way is about 400 billion stars, like our own sun. Amazing. Yeah. And then you find out, wow, with the Hubble telescope, we found 2 trillion galaxies. How do you know? How do they do that? Well, you just look at a tiny patch, the amount of it on the sky, and then you can multiply whatever you find there times the total distance. And they come up with 2 trillion galaxies, each of which might have, with Andromeda, we think there's 1 trillion stars in Andromeda. So anyway, that's what we're seeing. And now with the James Webb telescope, we're seeing 10 times that, 20 trillion. It's just just so amazing. And you're just looking at the Milky Way there. And you do know how many stars you can see on one side of the Earth at any one time?
Yeah, it's amazing. And I did find this, thanks to Stephen Bryant, who's here, who's going to come up and talk, George Coyne as well. I put it in the chat. It's medium.com/@Glenn Borchardt. And you do talk about the Eric Lerner on the Big Bang never happened. Of course, every time we get a better telescope, and every time we see more stuff, like what's always the MO? Wasn't it in the beginning of the 20th century, the universe was only maybe a couple, 500 million years old, then it went to 1 billion. Yeah. And every time we get a new telescope, we see really well-formed galaxies that shouldn't be there. Right. According to the Big Bang. And then, of course, on the Big Bang website, you literally see, I've watched it, edits that the universe's age is 13.78 billion years. Then you'll see an edit that it says it's now 13.74 billion years. I mean, it's just absurd. So what do you say about this will help a lot of people in the audience who are kind of new to this and have seen the James Webb. And it did bring up the possibility of the Big Bang being wrong. It came up again. And of course, in the beginning, everybody's excited, maybe it's wrong. And then all of a sudden mainstream people came in and said, no, you're interpreting it wrong. What was your take specifically about this for people maybe who don't know you and your work on the James Webb and what it was finding? It looks like you have an article here, right? In the Eric Lerner on the Big Bang never happened. It's kind of related to.
Eric had this book, he wrote this 30 years ago. And they're still debating, this is Eric here debating. This is one of my last essays. And I give a link to the thing. You can watch the whole thing. Yeah, that's
right. Right.
And then there was an interesting little thing with this fellow who was 9 years old, just graduated from high school, and he had a little discussion with DeGrasse, and
oh boy,
he hit it right on the head. I've got a list here on this site of 19 falsifications of the Big Bang theory, and he hit the first one, and he said, doctor, I don't believe in the Big Bang anymore. I have my own theory. And the reason it's not possible is that the energy can neither be created nor destroyed. Now, I say it more specifically, matter and the motion of matter can neither be destroyed or created. And if that's true, then right away, bingo, the Big Bang is gone. That totally. Now, DeGrasse was saying, well, if you did some experiments, you might get some evidence or whatever. We've done millions of experiments, and the conservation has always proven correct. So what's going on here? And so this is where guys like Neil deGrasse Tyson will drop out and say, well, philosophy has nothing to do with it. But here's your own equation that you have now neglected. And you have this. And the other one is like the second law of thermodynamics, where you talk about heat death of the universe. And remember, infinite universe theory solves that problem, because what the second law of thermodynamics says is that things eventually will come apart and the entropy will increase and so on. And what I came up with was what I call complementarity, is that I'd say that the second law of thermodynamics has a complement. What does that mean? In an infinite universe theory, what it means is that when something comes apart, its individual parts go somewhere else. Well, when they go somewhere else, what happens to them? Well, they form something else. So this is just like Newton's first law, where that object goes along forever, according to him, unless it hit. Well, it's really until it hits something else in the infinite universe theory, and that's where we changed classical mechanics to neomechanics, and it works wonderfully. It solves so many problems. It solves. Remember Ober's paradox? Remember what that was about? It says, well, if the light in an infinite universe theory,
yeah, of course, you'd see it.
Then the whole light
right.
be lit up like a star.
Right.
Because, okay, well, what the underlying assumption that Ober's made was that light could travel that far without anything happening to it.
Right.
You remember the galactic redshift that's responsible for the Big Bang interpretation? All that is saying is that light, whether it's a particle or a wave, can travel from point A to point B without losing energy.
Right.
That's not true. It's not possible. Right. Nothing. Yeah, like when you drive your car from A to B, guess what? You got to add some fuel. So not that you add fuel to these things, but what happens? The actual in wave motion, the velocity is controlled by the medium. And the only way you can lose energy is having the waves get longer. And that's what happens.
Right.
And the way I explain it, there's a lot of technical ways you might explain, but what I say is no two things are perfect in the universe, in the infinite. Remember, no two snowflakes are alike, and no two waves are alike. Remember what a wave is. A wave is a whole assembly of particles. And what you're saying is this assembly of particles will move. This motion that's been imparted is going to produce a wave over here that's identical. Can that be possible?
Right. No. Sure.
So over distance, what the only thing that can happen is for this wave to be weaker and the wavelength to be longer, because that's we know that long waves have less energy than short ones.
Right. Well, what's interesting too is the ether theory, which I know you're an etherist, and our theory, which is not an ether theory, they follow under the same rules. You know, the idea that the waves of particles, whether they're moving or it's in a medium, it's the same thing. You can't send. When I was a kid and I was growing up with Apollo, I always thought, oh, I'm going to get it. You get something in space, and you always hear them. What's going to happen to that? Probe that's going out there? Oh, it's going to go forever. It's just going to go forever, and it's it won't slow down. You don't think of that. You think of space as being absolutely empty, and then this idea that anything that travels through it is going to be unimpeded in some way, and that's that. No matter. Yeah, it doesn't. It's not going to happen.
Yeah.
Yeah.
And the way I explained Einstein's thing, if you read Relativity, Religious Roots, remember he hypothesized a photon. Essentially, he didn't call it that.
Sure.
But eventually it was called that, and he said this has no mass. It's massless.
Yeah.
It has perfectly empty space inside of it.
Yeah.
And perfectly empty space outside of it. So now this is used then, this idea is used in the Big Bang theory. See? So, and it's nonsense. We have no evidence for anything like that. Like if you ask somebody, okay, you hypothesize a photon. Well, tell me what the structure of the photon is. Nobody knows.
Nobody knows. Yeah. It's like quarks. If you look up quarks, you see a circle with 3 quarks in it that are all circles, and they have squiggly lines behind. There's no physicality.
Yeah. But anyway, there's no structure given for a photon, and it doesn't exist. It's imaginary, just like perfectly empty space. Remember, one thing I'd like to bring up is that, and I learned this when I did my follow-up. I invented this equation in which I was comparing two samples of volcanic ash, right? And if they were perfectly similar, my equation my coefficient would give a value of 1.0. And if we're totally dissimilar in their chemical contents, then I would get a value of 0. Well, it turns out there's no such thing. It's always something in between. And so perfectly empty space doesn't exist. That's imaginary. You got to remember.
Right, of course.
And then on the other side, you have perfectly solid matter. That also is imaginary. Real things are always in between. Remember, hydrogen has you have mostly empty space in it, filled with ether, of course, but you have electron going around, neutron. So anyway, that's the kind of thing we're seeing. It's like when you go through your doorway, is that perfectly empty space? No.
Yeah,
you have
of course.
push aside these weaker microcosms called nitrogen and oxygen, right, to get through that doorway. And so that's what has happened. And we use idealism all the time in science. And one of the things is just what I explained, is that perfectly empty space and perfectly solid matter that's idealization. But we have to remember, philosophically, they can't exist. We can use them in our work to help us understand what does exist. And that's the key in philosophy. And like people say, well, I have a hard time imagining infinity, and that the universe goes on and is infinite in time and so on. And people have this real problem with it. And of course, you can't imagine that, but you can now see 20 trillion galaxies if you care to calculate them. And well, how much more do you need? How much more evidence do you need to accept infinity? And I know most everybody grew up with finity, right? I mean, that's where I started. And so that's hard for people to go. But once you flip from infinity to infinity, it's a big deal. The big deal.
Yeah,
that's why I'm saying we're dealing with the last cosmological revolution. Once we get done with that, the universe will be understood as infinite, and it'll be second nature to everybody.
Okay, I'm going to give you one question here from the audience, but then I'm going to bring up. We got two guests who are standing on your shoulders, as well as my father and I, George Coyne here today, and Stephen Bryant, to commemorate your award here. But we do have a question. Yeah, and we do have a question from a person here. Martusen asks, question to Glenn: what causes the motion of matter from point A to B, linear or curvilinear, to be sustained in its internal energy, which is always in motion?
Well, remember, you have to have infinite universe theory for that. In other words, remember, a lot of people would, in the past, would say, well, if you got a finite universe, then what's the first cause? Remember, that's the big conundrum for the cosmogonists. And with infinite universe theory, we don't have that problem. What causes motion of matter from point A to B is always some other thing. There's always something else to do this, getting matter to move from point A to B. There's no engine inside of this thing that causes this motion. And a lot of people think of it as internal energy causing the motion of the entire particle. Of course, the internal energy is important for just keeping that particular microcosm in being able to survive what happens in the macrocosm. And one example I give about that is take a helium balloon. It's spherical, like a lot of our cosmological objects. Why is it that way? Well, inside you have helium molecules banging around, and they push against the boundary. And what's pushing the other way? Well, in the case of the helium balloon on Earth, it's the atmosphere, right? Nitrogen, oxygen in the atmosphere pushing in the other direction. Yeah, so that's what's happening. And now I've got a very complicated thing about curvilinear motion, say motion around a cosmic body. What is that? And
that's a gravitational idea, right? A gravitational field idea.
My gravitational idea involves that, and I explained Michelson-Morley basically that Michelson-Morley proved that ether's entrained. That is, it's accumulated around the Earth. The reason is gravitation is an acceleration. Now, Newton should have known this. That's one negative on his part. The gravitation is well known to be an acceleration. Well, what happens? How do you get an acceleration? Object A has to hit object B. What happens to object A?
There's
Object
a
B,
reaction.
yeah, if you do billiards, you know, object B speeds up and object A slows down. Duh. That's what I call ether deceleration theory. So that's what gravitation's all about. So all around a cosmic body will be dark matter, which they call it now, and it's just decelerated ether, and that makes a big difference on what happens. And we've got various data like pound replica that helps us to understand that the reason you have gravitation is that you have ether particles that are traveling really fast distally, far away from objects, and they bang around onto objects. They become decelerated. And so now when you do a Michelson-Morley experiment, if you do it at sea level, like they sort of did, you get a very low value of what they were trying to measure. They were trying to measure the motion of the Earth around the sun. It's 30 kilometers per second. And if they got that, then they would say, all right, we have a stationary ether and we have an ether wind when we go through it. But it turns out that they only got about like 5%. What really happened was that, and I show this in a couple of my books, there's an effect of altitude. So the further you go away from the Earth, the larger this number is. It's not 30 unless you went to satellite level, but if you're talking about 10,000 feet or so, you'll get about 10 kilometers per second, which is telling you that this halo of dark matter, or what you want to call it, decelerated ether, is essentially diminishing. Its effect is diminishing, just like you would expect.
Yeah, and I would, yeah, I understand that. It's a very good model. I do have a question here from somebody who actually, that you can make donations to the CMPS, and if you do, we can put your question up here. I don't know the answer to it myself either, but Dr. Broken mentioned a compliment. Is there a potential relation to knot theory? Do you know what that is,
I don't know anything about that.
Okay, doesn't know about knot theory. Okay, all right. Well, I'll just put that up there. We have a lot of people talking about have questions, but I do want to get to people here who have been sitting around. So I think I'll bring in George Coyne. George, you're there? I'm gonna bring him in. I guess he has something he's written. He wants to talk about you and your work. George, hello.
Hi. Can you hear me okay?
Oh yeah, we can hear you. Both on the East Coast. So I know George and I met in Vancouver when through a mutual friend, Duncan Shaw. Right. So you are in Vancouver, Canada, one of the most beautiful places, I'll tell you. I don't know who has more snow right now, Glenn Borchardt or George Coyne.
Actually, we were supposed to get snow this morning, but there's nothing.
Oh, there you go.
We got 400 inches so far. So
they did 30 centimeters, so nothing came down.
So George, obviously your work really almost doesn't exist as well, at least a lot of your recent work, because of Glenn. First of all, congratulations to Glenn for receiving this award from all of us at the CMPS. But you said did you want to read something? Is that what you want to say?
I prepared a couple of remarks. First, I'd like to compliment Glenn on how incredibly young he looks. I can't believe it. He betrays the idea of aging, where he's slow down mentally and slow down. I mean,
no, what he found out.
The most 20-year-olds.
He's found out how to block the microcosm and macrocosm so that it doesn't affect aging as quickly. So I really think that something's going on there. He's not telling us about it, and there's always a devious side to scientific genius.
No, I just put a blanket over my head all the time.
This man's age is not what you think. You know how old he is.
Yeah, exactly. Okay, George. So did you want to read something?
Anyways, I'll just let you know that I represent Glenn's Progressive Science Institute for the Vancouver Lower Mainland, and I've contributed many blogs to his weekly blog. It is a great privilege to have been invited by David to say some words about how I discovered Glenn's work. On November 25th, 2014, I was searching the internet to see whether anyone besides myself had the hypothesis that time is the motion of matter. Within a few seconds, I arrived at Glenn's The Scientific Worldview.com site. His November 30th, 2011 blog titled Time is Motion greatly impressed me. As a result, by 8:25 p.m. that day, I had composed a comment on this subject, which I posted on his site. I was pleased to see that Glenn liked it and reviewed it positively by commenting, "You have presented an excellent summary of our realization that time is motion. You have touched on all the important points. It is great to see yet another thinker who hasn't been a victim of the philosophical struggle. You are correct that the space-time concept is confusing. That is the way it is supposed to be." He means that's the way science right now is. They want it to be confusing. Otherwise, the Big Bang could not exist. The general rule is that determinism seeks clarity and that indeterminism seeks obscuration. And then he said, "By the way, you're 10 years ahead of me in giving up on time as matter." End of quote. And that was very encouraging comment, and that motivated me to continue my exploration on this. Glenn's appreciation of my various comments on his blog led to him inviting me to write blogs for his site, which I accepted. Glenn's responses to these guest blogs were a significant factor in giving me the confidence to write my first book, Notfinity Process, 2017, in which I cite several of his books. And now here's why I think that Glenn deserves this Lifetime Achievement Award. The measure of a successful life is not how much money, possessions, or power one accumulates. It is not even what one accomplishes in terms of one's profession or work. Although it is wonderful to contribute some marvelous scientific theory that explains the workings of the universe better than any previous theory, which Glenn may have done, even that pales in comparison to the true measure of success. One who treats everyone with kindness and compassion while having their true best interests in mind whenever interacting with them is truly a successful human being. Glenn Borchardt exemplifies these qualities to the highest level. I have been incredibly fortunate in my life to not only discover his scientific work, including his infinite universe theory, but also to get to know him over these last 8.5 years. And I'd like everyone to check out his medium.com blog this Monday on how the latest James Webb Space Telescope images contradict the Big Bang Theory, which includes some comments I sent to him. Thank you, Glenn.
Thank you so much. And yeah, your email was great, and it's going to be up on Monday. So yeah, I really appreciate all your work, and it was really neat that you looked at, found Time is Motion. That's our most popular blog. And we have people who write in like you did. It's like, I always thought that time was motion, but they talk about time being an object or something. And of course, it's not. It doesn't exist. It would be nice if it did. Then I could write another dozen books or something, and you could give me some time. But no, it doesn't exist. It's just motion. And this is the puzzle that people have. And that's why I use, in the fourth assumption, I use that matter and motion are inseparable. You can't separate them into two parts. They're not two separate things. But matter always is in motion, and motion always has to be of matter. So when you talk about, like some of the theoretical physicists do, like matterless motion, remember when you have E equals mc squared, apparently you lose some matter or mass, and then it goes flickering off as matterless motion, which is what they think energy is. Energy is really just a calculation. Remember, we were just calculating what is happening to matter in motion. And so we need to get back to that. And that's, I think, Dave had a nice little Saturday on physicality. What is physicality? Well, that's matter in motion. It's really simple. And it's sort of like, well, how do you tell the difference between matter and motion? Those are the two phenomena that we have in the universe. And I say it like this: I can take a frog and put him in my pocket, but I can't take jumping and put it in my pocket.
That's right.
I can't do that. And it doesn't exist. It occurs. It occurs. That's the difference. And so I think the fact that you grabbed that right away was wonderful. I don't get theoretical physicists who can understand or even know that time is motion, because it's difficult for them. With Einstein, he objectified it. Remember, he made it a dimension.
Right.
And without his four, dimensions, the Big Bang would also be gone, because we don't have a central point for the Big Bang. Can't say it's next to Mars or anything like that. So that is what actually has happened with all this matter motion stuff, and we need to get back to that. And that's why when I talk about conservation, I talk about the conservation of matter. And you cannot destroy or create matter and motion. That's it. And I like it that you are able to comprehend that. And I get a lot of followers same way. They're not necessarily people who have studied physical stuff like, physics per se, but they have these questions. They're curious. That's the number one thing I like about you, is you're so curious. And you, of course, you do the consciousness part that I don't do, and you have that all down. That was really good part of your book and so on. So anyway, if right now there are certain people that cannot do what we are doing, and they have they're cosmogonists. So they assume the universe is finite and had a beginning. If you assume that, and you have no, you can pick that if you want, because we can't prove it. And they do that. And that's why they get these silly results. And a lot of people are happy with that. But there are other people who are curious and saying, I don't know about this exploding out of nothing stuff.
Well, listen, George. Thank you so much for coming on. And I've always, I was really skeptical. I remember when Duncan Shaw says, "There's this guy at the conference, and he wants to talk about consciousness." And I go, "Oh no, here we go," because you're thinking New Ager, and you're going to get this totally system that. Then I started talking with him, and I mean, he talks 1,000 miles an hour, almost like myself. But I was greatly intrigued, and I was really shocked to find out that, immediately when he said, "Oh yeah," and he started talking about work with Glenn Borchardt, and I go, "Okay, now this guy's on the right track." So it is a mindset. People get into it. I mean, I remember when we talked about gravity being, everything's a push, right? Everything's got to be a push. It's collision. You can't have attraction. And I gave our book just talking about our ideas at that time, and the guy put it on my desk because I can't get by the idea that gravity's a push. Well, what is it? Well, it's space-time. Well, space-time is all these tensor equations. Well, tensor equations are physical. I mean, here's a guy who's extremely smart in computer science, and they say these sentences that just you want to shake your head. How do people? I mean, you're right. I mean, there's some people in that state of mind. They're just never going to extract it. I guess they're just never going to extract that idea. Well, thank you so much, George, again for coming by. I'm going to bring somebody else up. I hope he's up and ready. All right, and that is Steve Bryant, another person who has obviously stood on your shoulders as a student of yours, and of course we're kind of all in the same club. So how can you not like somebody who's a student of Borchardt? So I'm going to bring him up. Steve Bryant, how are you?
Hey, good afternoon.
Hi, Steve. I haven't seen him for a while.
No, I haven't. We're going to have to remediate that quickly and get together.
Something about COVID, I think.
So everybody is everybody involved with you today who are close to you are on the West Coast, and I moved away from the West Coast, so I don't know what that all means. But Stephen, I'll let you go ahead and talk a little bit. Leave you to. For those who don't know Stephen Bryant, check out his Disrupting, Disruption. What's the exact name of your title?
Disruptive Rewriting the Rules of Physics.
Right, and it's modern mechanics, right?
Modern mechanics,
yeah, and of course, I know Glenn was very much involved with it. So you want to check out Steve's work as well. I mean, he's here, but I'll let you guys go. And Steve, why don't you tell us a little bit about how you met Glenn, and why you got involved and how that has affected your work.
Absolutely. So first off, Glenn, let me just say congratulations on the Lifetime
Thank you.
Achievement Award. I think it's a significant recognition of all that you've done. And I'll talk about what it means to me in terms of what this award represents in just a moment. But to answer David's question about how we met, it was actually an interesting story in that Glenn and I were both at a conference. I think it was at the University of Connecticut, if I'm right. It was either there or University of Maryland. It was one of those back east. And we were both talking at various times, and we had an opportunity to meet each other. And as we're having some conversations, we realized that we lived probably about 5 miles from each other as the crow flies here in the San Francisco Bay Area. So a very small world, and it took the conference and 3,000 miles away from where we lived to find each other. But I'm glad that we did, because as you'll see, part of our journey, part of our relationship has been one of, I'll call it mutual respect, mutual understanding. And the one thing I really appreciate most about Glenn is the alignment, and I'll say his integrity on how he approaches his work. What do I mean by that? When we talk about the I'll call it the disruptive community, or the community who has questions, sometimes it goes by dissident, etc. Sometimes that community can be fractured and can have a lot of various ideas. And when two people are talking, sometimes it's very hard for the two people to actually hear each other, because they're each trying to present their own ideas. And one of the things I really appreciated from my conversations with Glenn early on is that mutual respect and understanding. And so as he would share his ideas about something, he's also listening to what you're saying, and either accepting your ideas or perhaps challenging your ideas, but he's engaged in the conversation, not just in ham radio. There's this idea of someone being an alligator, which is all mouth, or someone else being an elephant, which is all ears. And I think you need to be kind of that balance. And Glenn's really found that, and I appreciated that in terms of our relationship and the conversations that we've had that have helped elevate me in terms of my understanding and how I just approach science in general. I think one of the areas, Glenn, that you've really helped me in, and I'll share this, you know it, but not everyone else does, is that, Glenn, you've been just an instrumental reviewer in many of my papers that I've written, also an early reviewer and commenter on my book, which I really appreciated, and I think your feedback has helped shape it in new ways. You were also a collaborator. We worked together on a joint paper. And I think that's significant as well, because it represents the power of, again, what I shared earlier, of that synergy of finding other folks that you can then build upon. And I think the other part that's really helped me most recently in terms of my academic journey was your being one of my references as I joined the Georgia Tech community in terms of my pursuit of a graduate degree there. So I just want to also acknowledge you and thank you for being part of my journey. And I don't think I could be where I'm at without your help in that path. And I definitely am really appreciative of what you've done for me there. In terms of your path and your work, I think the most important aspect for this community, for all communities, for the broader community to take from your work is to step out of whatever echo chamber that people find themselves in. And we're human. Every human is going to have biases, and those biases can be the foundation of echo chambers. And there, I mean, you can go out to Wikipedia and look for the gazillion biases out there, and we all have various ones of them that will manifest at different times. The one thing I really hope that people take away from Glenn's work and his approach is to use what's out there and question those echo chambers, question those biases, question those beliefs, take in new knowledge. And sometimes you'll accept that new knowledge, sometimes you'll reject that new knowledge. And maybe you'll extend a theory, maybe you'll create a new theory, maybe you'll align with the theory, or maybe you'll support an existing theory. As long as people are willing to question and entertain and explore those new ideas, I think that's what advances us, and that's what advances science. And Glenn, I just want to again say thank you for being at the forefront of making that happen through your work. And as I mentioned, as a colleague on this journey, I know that you embody all of what I just shared, and I am appreciative for your helping me in my journey. Congratulations.
Yeah. Thank you. Steve, I have a question for you. I remember at one time you when we first met, I think you said something about possibly doing a PhD at UC Berkeley. Could you tell me a little bit why you didn't do that? And I think it was theoretical physics, what you were going to do.
You know what? I think when we first met, that was my intent. And going back a little bit, right, my undergraduate was in computer science. And at the time I got my undergraduate degree, artificial intelligence, which has existed for 60 years, was more rule-based at that point and less machine learning based. And so about after I finished Disruptive, I got excited about machine learning and going back into the computer science space. And that's that's why I joined Georgia Tech. I have not given up on the idea of a PhD. And I may do that. If I do, it would be in computer science, probably more so than physics. And the one thing I have learned, Glenn, during my work at Georgia Tech was the additional discipline of research and writing and all the other things that it takes to produce quality work, things that you already embody in what you produce. I also feel that there is a path to marry lots of disciplines, as you've done in terms of your journey. So whether it's a PhD in computer science or some other field, I think those foundational core skills that you develop, and then your ability to, like I like to say now, go dig a hole in the forest where no one else has dug a hole before and hope that you find something is kind of paramount. So I may do that if I continue to give that some thought. It would probably be in artificial general intelligence, although I am working on some work right now that marries computer science and physics. So it will be theoretical physics, not there's a lot of work out there already that marries those two disciplines, but mine is looking specifically at a different angle. So I may pursue that as in the future. Haven't ruled that out.
I think you were kind of put off a little bit because of the kind of nonsense theoretical physics was producing, even at Berkeley, of course. One of the biggest cosmogonists was Joe Silk, who was there and he was pushing the Big Bang with 3 editions of his thing. And I was impressed with your website, Relativity Challenge.com, right? Is it?
Or yeah.
And I thought that was really great because you had some interaction with a lot of people and so on. And you had pointed out to me that what we have to do is we have to let the younger folks know about this stuff, because the older folks, they already know everything. They don't need to have any infinite universe theory stuff. And they really think Einstein was the god of physics and so on, and believe in relativity and all the other stuff that goes with it. And I thought, well, that was kind of neat that you just didn't do that because of the nonsense. Is that still you remember that to be the case?
It is, Glenn, and I would say that it goes deeper than that, right? I think many folks, probably yourself, I can speak for myself, maybe folks who are watching today have been kind of pushed aside when they're trying to publish a paper on, let's say, one of the preprint sites, right? And they're just kind of summarily dismissed, or I've had a paper which I just think is amazing, where the editor wrote back and said, even if a peer reviewer certifies your math is right, we will not publish it. Okay, so in other words, math isn't enough anymore.
Yeah.
So it's quite interesting, and what you're alluding to, I think, is a very important realization that I've had, which is just how political the field has become, because we like to think it stands on science, and it stands on math, and it stands on rationality, but in many ways it also stands on who you know. It also stands on political. It also stands on,
right,
are you rocking the boat? So there's a lot there that you either have to buy into it or not. Having said that, there's a lot of terrific physicists who have been part of my journey, so I'm not bashing the field or the people. It's the political aspect, which I think unfortunately is prevailing over the discipline of math, rationality, and science. And Glenn, I don't know if I froze or you froze.
I think he's frozen. He did have a little bit. I think he could be actually frozen because of the amount of snow they've gotten. So I'll kind of bring him down. One of the things that I'd like to ask you about you and Glenn's work is that what the relativity part. I know that you wrote a book where you're looking at relativity in a very disciplined way. And I did notice that when you were doing your book, how Glenn was, making a lot of comments and helping you out. What was it that got, he's going to be coming back. I'm sure he's going to reconnect. But what was it that got you into the relativistic part? And how did Glenn's work kind of get you, how do you say, help orient you with modern mechanics?
So I would say that what got me into the relativity space was a question, right? I would sit around with some friends at lunch, and we would come up with ideas for companies and brainstorm. And one day we were brainstorming on some idea about faster than light communications, and someone in the group said, well, that can't happen. And I said, why not? And someone said, because Einstein said so. And I said, well, why does Einstein get to make the rules? And they kind of laughed at me and said, well, Steve, you need to go learn about relativity. At which point I did. I took a course in relativity, and at first I was drinking the Kool-Aid. I could see where things, space-time curvature, I can see where that's coming from, etc. But I do have a nasty habit of rederiving equations, something I picked up in one of my first calculus courses. Where our instructor didn't want to teach us equations because he said, by the end of the term, you'll forget it. And his philosophy was, let me teach you how to derive it, because if you know how to derive it, that's going to stick with you for the rest of your life. And so I would try to derive Einstein's equations and found some things that didn't quite line up, and that led me down the rabbit hole. Then, after a bit of my own journey, I found at the time, the NPA conference, and that's where I met Glenn. And what struck me most about Glenn's work was that his assumptions in terms of how he was thinking about science made sense. And it didn't mean, and Glenn and I had many conversations about many of those assumptions where I might push back or whatever, and we'd hash it out. And eventually I said, okay, I get where you're coming from, et cetera. But his willingness to do that conversation and not just sit back and say, like other people, when they say, when you question it, what do they say? They say, oh, well, you don't understand it. Go read this beginning book. Or, well, you're a dissident, or you're this, or you're that. You never get any of that from Glenn, right? He's embracing you because he views you on that journey of acquiring knowledge. Mm-hmm. And I'd say that's one of the things that I was really drawn to when we first met.
Yeah, that is something he has. But I will tell you though, Glenn is very, very nice. You don't ever hear him kind of yell or get emotional, right? But man, he can tear things apart with a few words. My goodness. I remember many times. I remember we would be at the MPA conference, right? It would be mostly in Connecticut because of Dr. Eberly was the president, and she had that available, right? And then someone would talk, and of course, once I knew Glenn, it was always great to go up, and I'd go up to Glenn, and he would just, oh, that guy's talking about matterless motion or something, something like that. And he would just go in. I mean, he would always be in the back, but he would be sitting there in his mind, just kind of making a list of all the assumptions this person is getting wrong. And there was a person, what was his name? He was always telling everybody that they had to do their assumptions in NPA. What was his name? Neil. What was his last name? But Neil, yeah. Neil. Yeah, Neil Munch. And he would always get up there. And I don't know, I don't know how long what was the first year you got involved with the MPA, Glenn?
Oh, I presented the 10 assumptions in 2004, but I wasn't involved, through the internet from 96, early on.
Okay. So I was just wondering, because I remember there was a time where everyone who gave a paper, Neil Munch would be there with his hand up in the back going, and the person knew it. They just dreaded it, right? So they'd be talking, and you had no idea what their assumptions was. And Neil would get up, "Okay, what are your assumptions? I'm trying to figure out your assumptions. Is it kind of not even relevant unless you give us the assumptions, because how can we believe anything?" The guy was just ruthless. But I do remember Glenn many times coming back, and just with a few words, like he would just bam, right? And not only that, it would just kind of like, be like a wrestler you'd see, where they would just, a person who's like good at martial arts, who doesn't do a lot of flailing about, they just see the motion coming at you, and they just kind of boop, and then seeing all kinds of down. He is very kind, but man, he could tear it apart. I mean, I always like to go to Glenn because I'd say, okay, what's he going to say about this talk? So
I think in that 2004 meeting, I had mentioned a photon, and somebody questioned me on it, and they asked me, "What's a photon?"
Right.
It's just like, oh, I don't know. So it works both ways. And
Sure.
That's the neat thing about meetings like that, and also discussing things with you guys and Steve and George and so on, that you get to feel, what other people think. And then you try to, you're looking for, what do we do in science? It's contradictions. Right. If you want to do a thesis, it always involves a contradiction. Like you're trying to solve some problem that has not been solved, right? Like if we're looking at whether a fault is active or not, well, dig a trench and look at what it looks like. Look at what happens to the soil and all that. That fault is a good example. I'm talking about earthquake fault, not you, Steve, or anything. Mm-hmm. But anyway, a fault is a contradiction. You have one kind of rock on one side and then another kind of rock on the other side, and you ask the question, why is that? And then how does that hook up with what we feel when we have an earthquake, like the terrible one that we just had in Turkey? That's an example. And remember, we live Berkeley's very close to the Hayward Fault, and it is very similar to the fault in Turkey that just went off. And so killed more than 47,000 people. Right. Not that that's going to happen to us because our construction has been improved, but you can see contradiction is the name of the game in science, and that's what you're doing all the time. It's like, and when you were saying, well, you have to be able to criticize certain aspects, and I think what you had said about going to Berkeley for a PhD is that, no, really, what you have to do is you have to believe in Einstein, relativity, and the Big Bang before you get admitted.
Yeah. Oh man, I think we're freezing on the West Coast here, folks. So I'm going to put myself up. Oh, nope. I see some movement. I think we've lost Glenn again. I'm going to bring him down here. Are you there still, Steve?
Yeah, I'm still here. Yeah. I'm not sure what happened, but there's we've had some really interesting weather here in the Bay Area.
Yeah.
Snow level has fallen to 500 feet, and so I'm at sea level, and look out a window, you can see one of the big, call it a mountain, but it's a big hill near me, and there's snow covered, which living on the coast of California is kind of a wild sight. So
So you've one of the things it is you are a kind of a big thinker. You've been involved with a lot of areas. I've been in AI myself. In fact, working in now, my friend and I came up with a language for writing intelligent programs where machine learning is actually failing in NLP. So I'm all in that kind of area as well. It's interesting how it seems like a lot of people there seems to be two sets of people who really get into kind of this what we call questioning critical thinking. And I see people in computer science, and I see electrical engineers. Electrical engineers seem to be, and the MPA, seem to be some of the most feet on the ground people I've met. You got electrical. My dad's an electrical engineer. Harry Ricker's an electrical engineer. Other ones I know. But it's interesting to see work like Glenn's is scientific, but somehow it kind of, you are showing that too. It kind of creeps into other areas. It doesn't always manifest itself only in physics and the physical world. Have you found any crossovers with your work in so many different fields that you can see not only in Glenn's work, but in general? Is that something that happens with you in your thought process?
It's interesting. I think in computer science, there's almost a mindset difference, right? Of wanting to be right. And as a discipline, I think computer science is, I don't want to say it's unique, but it is interesting in how a large aspect of the discipline is about being wrong, right? So when you talk about testing and validation, which is a big discipline in software engineering, which is an intersection between computer science and engineering, it is about finding defects. It's about verifying something is correct to the best of your ability. But this is where you also, as a computer scientist, will always keep in the back of your mind that no matter how much testing that you do, you could have missed something. And that's the idea behind, 0-day defects and things that are, you see in the news. It doesn't mean that someone failed to test. It just means that the system's worked, 999 times or 9 million times or whatever. No one's triggered that particular edge case, as it's called, for the failure to happen. But failure's there, it just hasn't been triggered. And I think when I see someone like Dr. Tyson talk about relativity, and his defense of relativity is because it works. As a computer scientist, that kind of runs counter to the way that we think, because working isn't enough to definitively prove it. What it does do is it says it's validated, and it's validated because we haven't found anything wrong with it. But validated because we haven't found anything wrong with it is not the same thing.
Oh, sure.
As being proven 100% right.
Right.
That's where the difference is.
Yeah, I know Neil deGrasse Tyson. I made a video on my dissident channel about him laughing when he was asked point blank whether Einstein could be wrong. His first answer was laughing. And it seems it's kind of in what you're saying is the same way. My dad kind of says about our own ideas and theories. He says, we just try to be less wrong than someone before us. And the idea that people really do believe things are proven and are written in stone is just antithetic to, I think, science. Let's see if we can bring Glenn there. Are you there again?
Yeah, we have some problems here. Too much snow.
Well, listen, I want to kind of wrap this part up here, but Glenn, Stephen, thank you so much for coming on. If you haven't checked Steve's work out, you should look it up. He is a kind of person I would consider myself, which is a multidisciplinary person. And I was just talking with him, Glenn, how it's so true. I think the people who have kind of a multidisciplinary ideas, you start to have these bigger pictures. And I think there's a lot of things that your work kind of can creep into just a mindset for almost anything. So thank you so much, Steve, for your coming on here. I know it's early morning for you guys. This is the only, because of the Earth's Pacific Ocean being so big, this is where we kind of try to get the most people. But thank you so much. And congratulations on your work, Steve.
Thank you. And thank you. And Glenn, once again, congratulations. Well deserved.
Yeah. Thank you so much for being on. I really appreciate it. And for working with you. That was really great.
Yeah, no, absolutely. So let's see, we've got about 10 minutes left. I do want to ask you, I'm going to ask you for one more question. I kind of kept to the end. I always thought it is interesting. And that is, you've said this before. I know you've talked to me about it, but I think for those people, maybe, again, we get a lot of views on these, hundreds of views that turn into thousands of views. But you talk about 2050, kind of this cycle of, because one of the big questions is, okay, Dave D. Hilster in the CNPS, you're saying Glenn Borchardt is going to be, is written down in the history of science and is going to be important for the next couple hundred years, helping us, guiding us along. When is this going to happen? When is Glenn Borchardt going to be taught in schools and in science and universities? And you're laughing, but you actually have thought about that yourself. Maybe we have a few minutes left. Why don't you tell those who haven't heard about it? There's this 2050, and it's not like the Mayan prediction of the end of the world, but there are some data points. Why don't you talk about that? I think that would be an interesting way to wrap up today.
Yeah, in my books, I emphasize the population, and the population of humanity has been increasing exponentially up until 1989. And you had about 75 million people added to the planet. And it's been off and on decreasing ever since. So what does that mean? Well, in 89, there were 5 billion people. I'm writing in my first copy of the Scientific Worldview was done in 1984. And that was a review copy. And so 89, I updated it a little bit for 07 version. And this was really neat because it says, okay, there are 5 billion people. And how many are there going to be on the planet? Now, the various reference, population reference bureau and so on, UN, they're trying to get numbers. And it turns out that if you do a mirror image of the period before 89 and flip it over, you get a sine curve. Well, what does that tell you? Well, we're going to have 10 billion people on this planet. Why is it slowing down? Well, resources are tougher to get. Water is harder to get, and food and so on. So this is one reason that is slowing down. And it turns out it's easier to live in a city than on a farm. I lived on a farm. It's a lot of work. And a lot of people don't want to work that much, so they live in a city and so on. And anyway, this kind of shows a real slowdown in population growth about the year 2050. And what does that mean? That means a lot of stuff's going to happen. You're going to have a battle between socialism and capitalism at that point. And I think that's when people start changing their mind. This Big Bang is, it's a humanity thing. Why is it that all of a sudden we had this Big Bang during the big population growth? Is there anything connecting that? Normally I would think not, but it's kind of interesting that's the demise of the Big Bang Theory is going to take us almost 30 more years. I think it's resonant. That's it. And so I think it gets connected with this big. You can see it coming now with the confrontation between Russia and Ukraine and so on, and China and so on. You can see all this competition again. And I'm not predicting a big war or anything, but I think that there's still small wars. I'm not sure Ukraine can be considered a small war, but I think that's part of it, that civilization is becoming more of an island. Remember, it's very difficult to have, for example, capitalism on an island. What you do is you produce something and then you consume it, and everybody there is doing well. In the past, you had the possibility of exporting stuff and so on. So all this will be questioned. We're not the only ones questioning stuff, and the university is not the only ones trying to stop us from questioning. It's just there. And that's the neat thing about the internet. What we're doing now was unheard of, when I started this work, it wasn't there. And now it's there, and it's available to everybody who wants to, whoever's curious. That's why one of my best blogs was about, well, what's part does curiosity play in science? Well, what else? You're asking a question. You want an answer. That's what curiosity is about. Why is the sky blue and that kind of stuff? Little kids ask that. And now we ask, well, is the universe infinite or is it finite? And that's what science is all about. And humanity is finally getting out of its juvenile stage, which it's up until 89. And then now we're leading maturation. So when you get more and more people crowded in a place, what happens? Civilization breaks out. What happens? Remember, the number one political question is, no matter what your system is should we do it together or should we do it apart?
Mm-hmm.
Well, when you put more people in one place, you're going to be doing it together more than apart, right? That's kind of logical. And there are always people that want to do it individually, and of course, more power to them if you can. But it gets to be a little bit difficult. And then we have all this idea that people have to adapt to things. That you can see it all over the place. It's all over the internet. We got to adapt to whatever it is. We have a lot of, and I got a nice word, I guess it's been around, called catastrophizing. I have a friend who every time a little part breaks on the car, it's a catastrophe. and it's cause for many calls to different people to get the best price for fixing it and so on. And that's catastrophizing. And the news is like that. And sometimes I think maybe we should just shut it off because it's just running it over.
So
and
in
over.
2050, where you're saying that there's going to be a big change where people are going to just basically, things will break down and question. And then that's a possibility that what we're doing and talking about these days in the what quote unquote dissident community outside mainstream will be looked upon and saying you're going to look somewhere to try to find that.
Yeah, right. And of course, the Jack Webb telescope is challenging that right now. They're trying to figure out, well, how come we got these really elderly galaxies at so far a distance and aren't, because remember the theory says everything gets younger with distance because you're looking back in time. So if everything started at 13.8, well, then we should have a little babies out there, little tiny stars, or maybe nothing, but that's not what we have. And so it's that kind of stuff. When we become curious and look outside ourselves, we find power. And that's why talking to you and Steve and Jordan and so on, it's really important because we were eventually we're going to have a consensus.
Sure.
Like we have on, for example, we have a consensus that there's nitrogen and oxygen in the atmosphere. How about that? Nobody argues about that anymore, right? Because we have, but at one time there probably was a lot of debate about it, and that's what curiosity is all about. You eventually find out a lot.
Okay, well, listen, we are running out of time, so I do want to present you. We don't have a certificate, but we will get it. It will be this year, but we also will include, it'll be nicely framed. I haven't even got it at the Neo, but we're going to put that together. I've been busy, but I do want to present you officially here with our award. So let me put that up on the screen here. So this is just a formal recognition that of a lifetime achievement. Oh, look, it says Nick's Percival. Oh my gosh. Let me go. Wait. I've got to remove that. Hey, wait a minute, Nick. It's got everything else right. I forgot to, obviously change the name. So let me just take a look at that. No, we'll get this right. That's what I like about live TV. So what I call live TV. But yeah, let me just fix that for you, and we'll be right back with that. And there we go. And
that's okay.
There we go. No problem. No, I got it. It's all ready.
One thing I like about you, Dave, is you know how to pronounce my name.
Glenn Borchardt. Yeah. How do people say that? There we go. How do they say that?
Yeah.
Okay, so let me present this. So
that's how we say it in the Midwest. If you go to Germany, they say Borchardt.
Yeah, Borchardt.
I think they pronounce Bach wrong too. They probably say Botch.
Oh yeah, that's true. Well, I've been de Hitler before, so there you go. Yeah. So anyways, let me do this again. I apologize for that. But this is a Lifetime Achievement Award to Dr. Glenn Borchardt on Saturday, February 25th, 2023, for your decades of work in scientific philosophy, including the 10 assumptions of science, neomechanics, and the infinite universe theory. We really proudly present you with this, and so deserving. And we do hope that this will bring attention not only to other people about the importance of your work outside the group, but even inside the group, because we do have a new generation. They're out there that are watching us and what we do. And on behalf of all of the directors and everyone involved with the NPA through the CMPS, we are very proud and are honored to recognize your lifetime achievement of work today. So
thank you so much. It really is humbling for me, and it's going to cause me to have some more achievements, I think.
I don't think that's ever going to stop. It's going to stop when your matter in motion stops, but it really won't stop. It's just going to be reformed. But and as you say in determinism, you don't have a choice anyways. This is going to happen. It's all determined. So what's going forward? So it's all for that. But,
I think you're right, and this is one of the things that determine what I do. I think I'm thinking about another book,
Well, no, absolutely. I think you should keep going. And I really do want to say that, the two things that came out today, what we saw were, number one, your work is being adopted by many of us and diverse. It's not just ether models. We have other models. Your idea, I think the new generation, if I look at Jeff Yee, Laurie Gardy, myself, George, Stephen, all of us believe the Neomechanical World. People are convinced of the infinity, and they're also convinced that, they're 3 dimensions. They're not 4. It's a Newtonian world. And I think it's, you don't really have to, I don't have to convince anyone that you are important, because if you just look at the newer models out there, there are less mathematics. You have, of course, more mathematical models like Dr. Lucas, who is really, he does have physicality, but it's mostly math. Whereas you look at Jeff Yee or our model or other people's models, they don't have charge anymore. Charge is that magical plus and minus by Benjamin Franklin. So the upshot is, it's one thing to be honored and have great work. It's another to have people already following your footsteps. And it sounds like that a lot of people are still discovering you through the new website. What's it called again? Medium? So
right.
And again, you do want to check out his work. I'll put that up here. You can go to scientificphilosophy.org, and of course you'll get all the links. I think all the things, the Medium and all that are there, right? So check it out. So I guess we'll be talking to you in the future about your new work, and congratulations again. I was very happy. I wanted to do this sooner than later, because I was worried that we would find you frozen with your wife in icicles somewhere, and then we wouldn't have the chance of hoping to thaw you out to be able to do this. But certainly congratulations from all of us.
Thank you so much. And our only problem here is the interruptions on the internet.
No, that doesn't matter. Today and age, we know that happens, so it's just not even in our consciousness. But congratulations once again.
Yeah, thank you all for listening and participating in all my work.
Yes, no, it's going to continue. You have no choice, as I said. So I'm going to bring you down here. All right, we're going to leave. Thank you so much, Glenn, and congratulations. Yeah. Okay. So I don't know. I do, before I want to leave, say that we do this every week. And Ian, you're there. He's still there. I'd like to bring him up. Hey, Ian, how are you?
I'm fine, thanks, David, as I hope you are. I thought I was off the hook now, but...
Oh, no, because you have actually become, by proxy, you've become, our other presenter. I'm very happy. And so what did you think? You know a little bit about Glenn's work. I think it's rightly deserved with so many people looking at his work. How did you feel about our organization? You are part of honoring him.
Well, yes, certainly. I thought it was well merited. And... I have had a look at some of his work, obviously, and I suppose there's a bit of a bias there because it concurs a lot with my ideas. I mean, the infiniteness of the universe in space and time is something that I work on as a basic hypothesis, and also my use of the ether as a sort of a
Right.
medium
Right.
to describe phenomena. So
Exactly.
I found a lot of commonality between our views, and I've always found him to be well spoken and rational. And,
Oh boy, rational is a big one.
Yeah, indeed, and he's made a significant contribution in quite a number of areas. So I think one cannot descend from today's presentation. In fact, quite the contrary.
Yes.
And I'm glad to be part of it. I was all ears listening to everything. In fact, to be quite frank with you, I was glad to have a bit of a rest, from talking.
See, there you go. It's not easy. But I did want to bring you up, too, is we have some things coming up with you guys, right, on the more intense days. Why don't you just give us a kind of brief overview before we close? Doesn't have to be long, but maybe give us an idea of what would be coming up on those days.
Okay, well, maybe I just better get up my rough file here just to remind me.
Right. And for those who don't know, while he's doing that, we do try to alternate days, or at least bounce between the two. And that is very intense, more, how do you say, geeky, more in-depth looks at people's mathematics or concepts or whatever, sort of more like technical side of critical thinking. And Ian's been kind enough to be hosting those kinds of things coming up. And then I'll do the more general kind of overarching topics. So do you have a list of some of the things coming up?
Well, yes, provisionally, it hasn't been confirmed yet, so I'm a little uncertain about this. But next week, Nick Percival was endeavouring to arrange a talk by a Professor Amrit Sorley, I hope I'm pronouncing his name correctly, on bijective physics. You might like to look that up. But that hasn't been confirmed yet. I'm actually in correspondence with Nick on it.
Okay, no problem. These things are always can change, but we at least
actually, get a bit of Murphy's Law. I had sort of arrangements every 2 weeks, and unfortunately, they chose. These are sort of realtors I'm involved with. They chose the weeks that I'm on. So I've asked them if they could give me the other weeks, and I'll get a reply back from them on Monday.
Okay, but we'll all adjust. But what are some of the other topics that are possibly coming up?
Now, if you've been following this, or the participants, David, they'll know that James Keane, was quite brave in talking about a paper that had been produced by a gentleman by the name of Henri Cornier on photon mass theory. I say brave because we're on the 18th of March. This has been confirmed actually by Mr. Cornier. We're hoping to have a talk by him on his original paper on the photon mass.
Oh, nice. Very nice.
Applied this to many phenomena in physics.
Right. And then also people can get a hold of you as well, or myself, if they want to present things. So, all right, that's good. Yes, go ahead.
We're looking for that because you said we had things penciled in for March, and we have one or two things penciled in for April.
Right.
But we're always looking for people. So please do get in touch with either or both of us. Yes.
Yeah, but you do want to join Ian and all those people. I am busy every other Saturday myself. So thank you so lot, Ian, for that and in giving us an idea. Thanks so much.
Thank you, David.
Okay. So, you want to change it. So let's get out of here, man. The time has flown, or the motion has flown, or the processes. Boy, that's a problem. Once you get into this, you even catch yourself on words. But I do want to thank and congratulate once again Dr. Glenn Borchardt. Super well deserves. This is really a long time. It should have come before this, but thank goodness we did it before he and his wife froze out there in the tundra. But I want to thank everybody, and let's take this out of here. Here we go. Just don't forget, I'm David Hilscher. Stay thinking, stay critical. I am your science therapist trying to get you the promised land of becoming a critical thinker. That's the most important thing. Ciao for now.